Yeah, good evening, my dear students, my dear future makers and national builders. Welcome to ACE online platform. And here I am. We are going to discuss today ISRO mission. That means the preparation strategy for ISRO exam. And here I am going to deal the subject like discrete mathematical structures. And also I can give you the required inputs for AI, artificial intelligence. That is the newly introduced subject in ISRO syllabus, right? My dear, in discrete mathematics, um, whatever the 4 units we have in our gate part, the same thing available in ISRO syllabus also. Let me say, if you are preparing for gate examination, almost that preparation is more than enough for ISRO examination. If gate preparation is just like 100%, and if you put 60% of efforts for ISRO examination, that is really more than enough, right? My dear, here we have from our discrete mathematical structures, and we have the parts like math logic, mathematical logic you can say, and the second part is combinatorics, and the third part is graph, and the fourth part is set theory we have. Coming to the latest examination in 2023 gate, in 2023 ISRO examination, my dear, the pattern is somewhat, they asked the questions are somewhat in different way. But if you see the all previous year questions in 2017 paper and all previous papers, ISRO examination, what I analyzed is, if you focus on the concepts like graph and set theory, they are something like most frequent topics. Yeah, let me mention one more time. I already saying something like that. 23 paper scenario is different, but if you analyze all previous papers, it is different. Yeah, let us see the weightage like this. In 2007, 8, 9, 11, 15, 17, all weightages are available. The first subject what we have is DMS. In discrete mathematical structures, totally we got 45 questions from all the previous year papers we can say. And the trending just like the latest examination in 2023, here we have the 7 questions from this discrete mathematical structures. My dear, understand what is the portion of discrete mathematics, what is the syllabus, what is the content. According to the content, what is the weightage, right? You should compare these two things, right? So yeah, some network subject is there, really it has very good weightage, but coming to the syllabus wise, you have to prepare all layers, right? Layer 1 to layer 7, all layers you have to prepare. Yeah, OS some is something called, that is a good weightage, with 137 questions. And coming to the syllabus wise, it is almost like discrete mathematics. My dear, you take each and every subject. I am not saying any subject is more or any subject is less. Each and every subject is very important in competitive examination. But when you are focusing on the preparation, see the content, see the syllabus, and how much time you need to spend, and accordingly what is that subject weightage, right? You should go accordingly. Now here I am going to discuss all 2023 ISRO examination questions with detailed solutions. And let me add one more token here. Here we have AI and ML subject that is recently introduced. In 2023 gate, we got 2 questions, whereas one question is common from logic. You can treat it as both discrete and also first order logic. Yeah, let's say, yeah, And in 23 paper, if you want to go for a recent paper, the analysis is like this. You can take the weightage and according to that you can go your preparation strategy, you can say. Yeah, let's move. The question, we have something like graph theory. I hope you are reading the question. Analyze the question. Which of the following is true? Which of the following is true? In a graph, there are n vertices with e number of edges. The sum of degrees of all vertices in the given graph is 2 times of number of edges. That is first statement. And the second statement given is eccentricity of a connected graph, yeah, it should be a connected graph, can never be equals to the radius of the graph. And third statement comes to girth of the graph is the total number of edges in the shortest path, in the shortest cycle of the graph. Yeah, it's a total number of edges. They are just saying like a length of the shortest cycle. That is called something like girth according to the third statement. And coming to the fourth statement, graph with equal degree for all vertices is a multigraph, right? And different options are available. We have to choose the correct option from this. My dear, let us go to the first statement. Let us analyze this. So there are n vertices and e number of edges. Let me try to take a small simple graph like this. Now I am going to take a small simple graph. Okay. Here I want to take a graph like this. Coming to the set of vertices, let me consider some 10 vertices here. And whereas coming to the edges, let us take some edges like this. Yeah. My dear, see this graph. I hope you noticed this graph. This is a graph with n vertices. Here n is equals to 10. And coming to the number of edges, some 15 edges are available. And if you ask me what is the degree of a vertex here, the degree of a vertex, let me take vertex A or B or C. I think degree of every vertex is 3 here, the number of edges incidenting on that particular vertex. Yeah, it's 3. According to handshaking lemma, or you can say sum of degrees theorem, let us take sum of degrees of all vertices. Yeah, it comes to degree of vertex A is 3, degree of vertex B is 3, 3 plus 3 plus 3, like this 10 times. Yeah, 3 into 10, and the sum become as 30. 30 I can write it as 2 into 15. Yeah, 15 refers to the number of edges, you can say. Yes, my dear, not only for this graph, you can take any simple graph. You can apply sum of degrees theorem. According to sum of degrees theorem, the sum of degrees of all vertices is equals to 2 times of the edges, whatever the available in the first statement. I think the statement is true. Yeah, sum of degrees of all vertices is equals to 2 times of number of edges. Yeah, this statement is true, no doubt. And let us say, coming to the second statement, the eccentricity of a connected graph. Yes, if you want to use the word like eccentricity, it must be a connected graph. Never be equal to the radius of the graph. Why not? Why not it is? Let us see. Sir, here we can take a small example. Before going to that, what is eccentricity of a particular vertex? Let me say Vi. What you are going to do? You are going to find the distance of vertex Vi to every other vertex in the given graph. And from all the distances you are going to take the maximum of eccentricities. Yes, my dear, I want to say like this. The maximum of, sorry, not eccentricities, let like distance, distance of vertex Vi to V, yeah, Vi to V, or you can take in any manner. If you ask me what is the eccentricity of vertex V, let me say the maximum of distance of the particular vertex V to Vi, yeah, where for all Vi belongs to the set of vertices in the given graph, G you can say. From the vertex 2, I can find a distance to every other vertex in the graph, and where the distance is maximum, I can consider that maximum distance is nothing but eccentricity. Now in that case, let me use the last graph again. So if you see from vertex A, I can reach any other vertex in the graph. Let me say, can I go with 3 units? I can reach A to B within 1 unit. I can reach A to F within 1 unit. A to E within 1 unit. A to G, let me take 1, 2, 3 units. A to J, 1, 2, 3 units. And A to H, that is 2 units, and A to C, that is 3 units, 1, 2, 3. Similarly, A to D is also 3 units. My dear, what I am trying to convey is, there is a vertex called A. From this vertex A, you can reach any other 9 vertices in the graph in the maximum of 3 units distance. Some vertices I can reach within 1 unit, some vertices I can reach 2 units, some vertices I can reach maximum of 3 units. I hope my point is clear to you. Now I want to say something like this. Eccentricity of vertex in the above graph is 3, and it is not only for vertex A, it can be happens for every vertex in the given graph. Yes, you are right. The diameter of the graph is 3 units. The diameter of the graph is 3 units, and the radius of the graph is also 3 units. Now what's the problem? Why are you saying like this? The eccentricity of a vertex, it never be equals to the radius of a vertex. Why not? Here eccentricity of a vertex is equals to the radius of a vertex, radius of a given graph. In the second statement, eccentricity of a connected graph can never be equals to the radius of the graph. My dear, that statement is not at all correct. I hope you remember our classroom discussion. If eccentricity of a particular vertex is equals to the radius of a graph, we can call that vertex as a central point actually. We can call it as a central point. And coming to the third statement, the girth of the graph is nothing but total number of edges in shortest cycle. Yes, we can find cycle in the graph. If the given graph is a simple graph, then the shortest cycle can be C3 or C4 or C5 or C6. Something depends on the given question. Less than C3, it's not possible, right? But whatever the shortest cycle available in the graph, I can find the length of the shortest cycle and I can call it as girth of the graph. Yes, that statement is 100% correct. And if you take the length of the longest cycle, you can call it as circumference of the graph. Here the length of the shortest cycle you are saying, so it is a girth of the graph. So the confirmation is the third statement is true. And coming to the fourth statement, graph with equal degree of all vertices is a multigraph. Why it is? Why it is? Here I have taken a graph like this. Again I will take the same example. This example graph, you know very well, it is nothing but a non-directed graph with 10 vertices and 15 edges, and degree of every vertex is 3. Yeah, you can call it as a 3 regular graph, and it is our famous Peterson's graph, and this Peterson's graph can act as a counter example for many concepts of graph theory. I hope you know that. Now coming to the conclusion, what can I say? Degree of every vertex is something like 3. If it is having equal degree, I can call it as a regular graph, but you are saying multigraph. My dear, the idea of multigraph is really different. If there are 2 vertices in the graph, just like V1 is one vertex, V2 is another vertex, and if you have a direct or non-direct dedicated edge, yes, if they are joined with multiple edges, if many edges are available in the graph, E1, E2, E3, you can call them as parallel edges. The parallel edges are available between same pair of vertices, V1, V2. I hope my words are clear to you. I am not using the word like a path. I am clearly using like edges, right? 2 vertices are there, you are using many edges to join them. That edges we can call them as parallel edges. And if parallel edges are available, then you can call that graph as a multigraph. No parallel edges are available, no self loops are available, then you can call it as a simple graph. My dear, I am not just discussing this question, I am just discussing the extension concepts for these. Maybe in the next time if they want to go for next level, it may helps you in your preparation. It's going to be just like a revision. I hope you are getting my idea. So the fourth statement is not true, my dear. So only the statements 1 and 3 are going to be correct, right? So 1, 2, 3, 2, 3, 4, not like this. None of the above, only first statement and third statement are correct. One second. Eccentricity of a connected graph can never be equals to the radius of a graph. Yes, second statement is false. Yeah, eccentricity can be equals to the radius of a graph. I hope my conclusion is clear to you. Now see next question. Go through the question, take a moment, and I will check how you are watching this. And if you want to give any response in comments, you please comment. May I know what is answer to this next question? If there are 5 faces, and 9 vertices in an undirected planar graph, excuse me. Yeah. 5 faces are available. Let me take the number of faces, you can say, you can call it as F, or number of regions are, that is 5 available here, and 9 vertices, yeah, N or V, that is 9 vertices. It's given a planar graph, the graph without any cross edges. Cross edges are not allowed. Then only the graph can divide the 2-dimensional plane into number of bounded regions, right? Yes, sir, the given graph is a planar one. For planar graph, we can make it R plus V is equals to E plus 2. R refers to 5 plus 9, that is E plus 2, I think is 12. Number of edges are 12. That is correct answer. And here you should notice whatever the formulas applicable for simple graph, you can apply all simple graph formulas to the planar graph. But don't apply planar graph formulas to the simple graph. Now you can say planar graph is just like one classification in simple graph, isn't it? Fine. Now see this, find the minimum spanning distance. Yeah, you can treat this question as algorithms, you can also treat this question as discrete, no issue. Yeah, there are something like 5 vertices. We have A, B, C, D and E here. Let me use Kruskal's approach. When you are finding MST, you can go with Kruskal's or Prim's. The available minimum edge weight is 1 unit, I feel. After 1 unit, 2 units available here. And then we have 3 units. Then can I take 4 units? Is it right? Yes, you should not go for 4 units. If you take 4 units, it forms a cycle, my dear. That is not allowed in MST. So don't take 4 units. Let's move with 5 units. Now this is some MST we got, and spanning distance comes to 1 plus 5, 6, 6 plus 3, 9, 9 plus 2, 11 units, right? It is spanning distance comes to 11 units. The minimum spanning distance, what we are going to get here, that is 11 units. And including with this, there is a question like corresponding number of edges. I think to solve this question, number of edges means we have no need to take too much stress, because if there are n vertices in the given graph, whatever it may be, binary tree, spanning tree, minimum spanning tree, whatever the words they are going to use, finally it is a tree, right? If it is a tree means n vertices, n minus 1 edges. Without looking too much about the question, I can simply say that 5 vertices and 4 edges can be available. So 11 comma 4 is the correct answer. 11 is the minimum spanning distance and 4 is the number of edges available in the resultant minimal spanning tree. My dear, B is correct answer to this. Let us see another question. I hope you can respond with correct answer to this. Am I checked? Anujit is responding like happy teachers day, and Joshi is given formula for R plus V is equals to E plus 2. Yeah, Anujit, thank you. Apart from wishes, if you solve the problem, I feel somewhat more happy than this. Yeah, please solve the question and give me a response. The maximum number of simple graphs possible with n vertices. N vertices. Yes, 2 power n into n minus 1 by 2. You may have some different options like this. My dear, let me say the actual concept here. So if you have something like n vertices with us, yeah, I am saying the graph consists n vertices. the number of vertices in the given graph is equals to n. In that case, the maximum possible number of edges, the maximum possible number of edges is equals to what? Right? Yeah, you can take some graph like this. Let us suppose n is equals to some 4 vertices A, B, C, D. This is one graph. You may not assign any edge. This is one graph. Yes, you have to agree. And let me take another thing. A, B, C, D. This is another graph. And let me take some graph in this way. E1 here, E2 here. This is another graph. The set of vertices like A, B, C, D. Now I want to take E3 here, E4 here. Till now what I did? I have taken one graph here, G1 let me say, and this is G2 let me say, this is third graph G3, and this is let me say G4 graph. Now I want to take a graph like this, a simple graph with a set of vertices and edges like E1, E2, E3, E4, E5, E6, all possible edges I have taken. Yes, all possible edges I have taken. My dear, how I am getting the edge? Sir, edge is nothing but it's a connection between two pair of vertices. Here you are using something like 4 vertices. If you are using 4 vertices, from 4 vertices you can prepare maximum 4 C2 edges. Any 2 pairs you can choose. Any 2 vertices you can choose, that means one pair. Any 2 vertices from the available 4 vertices. Sometimes you can choose AB, sometimes you can choose CD, sometimes you don't choose anything. Now the maximum possible number of edges 4C2, I agree that. But how I am preparing the graph? In some graphs, I don't take edge E1. In some graph, I can take the edge E1. In some graph, I don't take E1. Are you getting that? In some graphs, when I am constructing a simple graph, I don't take the edge E2. Sometimes I will take the edge E2. Sometimes I don't take the edge E2. That means every edge is having 2 possibilities. I may assign the edge or I may not assign the edge. Yeah, the first edge I may assign it, I may not assign it. The first edge is having 2 possibilities. Yes sir, here you have the first edge E1, E2, E3, E4, E5, E6. In the last example, you have taken something like, what do you say, 6 edges. 4 vertices and 6 edges, the complete graph on 4 vertices, just like K4 you have taken. In that scenario, what you are going to take is, this edge is having 2 possibilities, this one is having 2 possibilities in the sense, you may consider that edge in the graph or you may not consider that edge in the graph. And this one is having 2 possibilities, this one is having 2 possibilities, this one have 2. Like this, 2 power 6 possibilities you can say. The 6 is coming like 2 power 4C2. 6 is nothing but 4C2, right? And if I go to for generalization, in the general format is 2 power NC2. 2 power NC2 refers to 2 power NC2, n into n minus 1 by 2. My dear, this is the logic. This is the actual derivation for the formula. Yeah, I considered some example. With the example I shown, the same thing I can also go with something called n vertices also, right? So if you understand the formula in a proper way, I hope you have no need to refer the formula or by heart the formula one more time. So this is the time you have to fix in your brain the maximum possible number of edges in a simple graph is NC2 and the maximum possible number of graphs possible is 2 power NC2. 2 power NC2 refers to, you can say that, yes, 2 power n into n minus 1 by 2. I hope it is clear to you. My dear, if you refer something called some 5 to 10 papers of, let me say 5 papers. If you refer 5 papers of ISRO examination, out of 5 papers, almost 4 papers consist this question. Repeated question it is. Every time they will ask this question. The possible number of simple graphs, the possible number of simple graphs, and also number of spanning trees, the number of spanning trees possible on n vertices, the formula is n power n minus 2. Repeatedly they are asking this question. And also the question on set operations. Set operations, I hope you remember the set operations, just like the basic operations, set difference. Here I have written delta. Can you say what is delta? Yeah, symmetric difference, A delta B it is, or you can also call it as A Boolean sum B. If you ask me to write formula A Boolean sum B, let me say like this, it is nothing but all minus common and also A alone or B alone. X belongs to A or X belongs to B, but not both. Yeah, these 3 questions are repeated. You see previous papers, and either I am really saying the fact or not, you can verify, right? So this is the discussion about graph, and there is one question based on characteristic of length m, the number of substrings possible. So if m strings, the characteristic length is m, how many substrings are possible, right? Can you say the answer to this? Different options are available. So the length of the string is, m here. Let us suppose m is equals to some 4, which means that I am considering a string, consider a string just like ABCD. Okay, for this ABCD string, I want to construct the number of substrings. My dear, I hope you know some basic knowledge from programming is required. String is nothing but group of characters. And if you take AB, I can take it as a substring of length 2. If you say AC, AB is a substring to this one, okay. But AC cannot be the substring. First try to make that point clear, right? Here there is a string ABCD and the number of substrings possible, of length 1 unit, of length m is I don't say m, let me take it as L, that is better. Length 1 unit, length 2 units, length 3 units, length 4 units, right? If I go with length 1, I can prepare a substrings like A, B, C, D. Yeah, I can prepare 4 substrings like this. If I take length 2 from the string A, B, C, D, I can take like A, B, BC or CD. like three substrings I can prepare. Yes, you are right. If there are n length of the string is length n or m. If you want to take a pairs, two strings like that, you can prepare m minus 1 or n minus 1. There is a string of 100 characters. You can prepare 99 pairs from that. And let me take 3. ABC you can choose, BCD you can choose. Yes, my dear, it is the application of combinatorics. If a string can be substring to itself, yes, you are right. It can be like this. As you mentioned that all are non-empty substrings, I am not taking the empty string or null string. The answer comes to 4 plus 3 plus 2 plus 1, sum of 4 natural numbers. If it is m like this, it comes to m plus m minus 1 plus m minus 2 plus so on up to 1. The sum of first m natural numbers, that comes to m into m plus 1 by 2. That is the required answer. Fine. M into m plus 1 by 2, that is the correct one, my dear. I hope you got it. Now see this, a truth table will need how many rows if there are n variables. As I told you earlier, in gate preparation, if it is just like 100%, ISRO preparation is just 60% of it, particularly in our discrete mathematical structures. If you focus more on 1 mark questions, that is almost 99% enough. You see this question, there is a n propositional variables, how many rows you can get, how many rows? If there is only one propositional variables, here I am saying like number of propositional variables, let me write like a variables. And the number of rows. Yeah, there is one variable, you have two possibilities, that can be true or that can be false. And if there are two variables, yes my dear, if there are two variables, just like P here, Q here. This P is having two possibilities, just like true or false. And this Q is having also two possibilities. By using the product rule in combinatorics, here two ways, here two ways, then the total number of ways comes to 2 square. And if you have three variables just like R, yeah, again you can get 2 more ways, 2 power 3 it becomes. Let me complete properly. If there are two variables, you can get 2 square ways. If there are some three variables, then the number of rows are 2 power 3. In this scenario, if there are n variables with us, then the truth table consists 2 power n rows, right? 2 power n rows. Answer is 2 power n. Yeah, option C, 2 raised to n is the correct answer to this. And say this, my dear, they mention this question is just like artificial intelligence, but it's a common part of logic, you can say. You can treat it as some common area question. So just to see, which of the following is not connective of the first order logic reference to AI, artificial intelligence? The first option they given as this symbol, this is nothing but and symbol, you can say. Where we can use this? We can use this in conjunction, right? If all given propositional variables are true, then only their conjunction can be true. Otherwise, in the sense if one of them is false, the result is going to be false. Yeah, in logic part we can P1 and P2 and P3. In case of argument, if all given premises are true, then only the conclusion can be true. If one of the premises is false, the set of premises cannot be consistent. They cannot give you any proper possible conclusion from that. Yeah. And let me take B. The given logical operator is, this is R. This one we can use it as in disjunction, right? Just like a PRQ you can say. In existential quantifier we can say there exists some x p of x. In logic part, if at least one object in the universe can make the given statement is true, then the quantifier there exists some x p of x can be true. And coming to C, C I have something. Let me take D. D is a negation. Yeah, it's like a negation. What is negation of the formula? It may be simple propositional formula or it may be quantified statement, whatever it is. The negation definition is same. If the given statement is true, then the negation statement becomes false. If the given statement is false, then the negation statement can be true. If the given statement is a quantified statement, just like predicate formula, whatever it is, the same it's going to be toggle. Yes, my dear, I can say some statement like Bombay is the capital of India. The negation statement becomes Bombay is not the capital of India. That's it. Either New Delhi is the capital of India, Chandigarh is the capital of India, whatever, that thing doesn't matter. I can say simply not. That's it. If the given statement is true, the negation is going to be false. If the given statement is statement refers to maybe preposition, maybe predicate formula, you just read it, right? In habitual manner, I can say statement, and you know that every statement cannot be a proposition. So yeah, take it as a grant. So negation of something, it's going to be true or false. These things we are definitely use in logic, where we are using also, I just stressed now. But coming to this symbol, here we don't use this type of generator or less than, greater than symbol in our logic. So this is not the logical connective in artificial intelligence. That could be our answer, C, right? My dear, see this Bayesian network question. There is another question from AI. So the hybrid Bayesian network contains what type of variables? It contains only continuous variables. It contains only discrete variables. It contains only discrete and discontinuous. How funny it is. Continuous and discrete variable. My dear, understand the word discrete. The word discrete refers to, it is non-continuous, or you can say discontinuous. Right? In Bayesian networks, we are going to use both things, right? We are going to use both things. Let me say I want to take some part like this. There is a BBN with us, Bayesian belief network. In the classroom discussion, I think this type of diagram we have taken many times. But students also asked me, sir, you taken many same example. My dear, that is the famous example in results. from the results textbook. It can cover all areas. That is the reason we are taking the same example. But don't worry, I will do some little bit change here. So it's a cloudy. It's a cloudy. And here we have rain and sprinklers. So in place of rain, just for your satisfaction, I can take temperature, and here it's rain, and it's a wet grass. Let us take this directed acyclic graph. Let us take this directed acyclic graph and also following all topological ordering or topological sorting. My dear, see this. Here what we have, cloudy is one variable. The probability of cloudy, everything you can discuss. And rain. Rain can be happens or rain may not be happens. There are only two things here. So it is just like a discrete variable. Yeah, my dear, discrete variable, it's a finite. It's finite. It's not like a continuous manner. It's a discontinuous manner. You can say true or you can say false. That's it. That's it. There ends the matter. But coming to temperature, on that particular city, I know that the temperature can range from 26 degrees centigrade to something called 47 degrees centigrade. Let us suppose, just for consideration, right? 26, 47. My dear, in this given range, this variable temperature is going to be it's like a continuous variable. It is not discontinuous. I can make it like this. I can take it as 37.1, 37.2, 37.3, 37.4, 37.5, 37.9, 37.11. I will go like this. It is going to be continuous. So what can I say is, it is a variable. It is not a discrete variable. It's a continuous variable. And my conclusion comes to, if the given network is a hybrid network, hybrid Bayesian belief network, it consists both continuous and non-continuous variables, or you can say discrete and continuous variables. And coming to the conclusion, what you can say, yeah, let me go with the last option. It contains discrete variables and also continuous variables. Both it can. Option D is the correct one. Yes, my dear, I hope all of you understood. This is the idea of 2023 ISRO examination paper, and moreover, my dear, myself, Vamshi Krishna, I am the faculty in AS Engineering Academy in CSE department, and I completed MTech CSE and doing PhD in artificial intelligence, and I have more than 10 years of experience in conducting GATE classes. And also coming to our AS Engineering Academy, I have approx 4 years of experience in our institute. And I hope you enjoyed the session. It is grateful to you, and thank you very much for your valuable time. And I am going to let me say, like it's something like a false statement. In the life, all the things are not very best, but even it is a false statement also. But I wish you, as a teacher, on the occasion of Happy Teachers Day, I wish you all very good luck. I wish you all very good luck in each and every aspect. And don't forget the preparation. Try to enjoy the preparation. Never give up, and just move on in your work. Enjoy the work, automatically results follow you. Don't run for results or something else. Okay. My dear, I hope you enjoyed the session, and let me know in comment section whatever If you comment, I can take it as a grant. But if you comment something, it is very good. It's helpful to all in all other aspects. And thank you very much, students. That is about today's session. I hope it is useful to you. Bye.